So in problem number 2, part A, we need to use the data in the table to estimate the rate at which the number of people waiting in line was changing at the time 5:30 p.m., which is t is equal to 5.5. So we're looking for a rate. In the table, they gave us L of t, and L of t are the various values shown in the table, which is about the number of people waiting in line. So we need the rate, so we need the derivative. So L prime of 5.5 is approximately the value of L of 7 minus L of 4 over 7 minus 4. So that's 150 minus 126 over that 7 minus 4, which comes out to 8. Showing our computations, we did that, and we have to indicate units of measure. L of t is being measured in people, and then t is being measured in hours. So we'll have people per hour. Part B says we have to use a trapezoidal sum, and we have 3 subintervals. They do not say the word equal. Estimate the average number of people waiting in line during the first 4 hours. So trapezoidal sum, first 4 hours, we're doing the average number of people. So the delta t for the first trapezoid is 1, for the second trapezoid is 2, and for the third one is 1. We're only going 0 to 4, 3 trapezoids. Those are the bases of our trapezoids, and then we're going to do the average value. So for our average value, we're going to have 1 over b minus a, so that's going to be 1 over 4 minus 0. Anti-deriving from 0 to 4 of our L of t equation. So we're going to have 1 over 4, and then doing trapezoid sum, we'll have 1/2, 2 bases of 120 and 156, and the first height is 1. The next 2 bases are 156 and 176 with a height of 2, and the last trapezoid has a base of 176 and 126 with a height of 1. This comes out to 155.25, and then we need our units in the problem. For that interval from 0 to 9, we're going to try to figure out the fewest number of times in which L prime of t must equal 0. So we're looking to think about that slope of L of t, so that's going to be using MVT. In order to use that mean value theorem, we must have a continuous and differentiable function. So that function L of t is differentiable. Since we were given a twice differentiable function for L of t, so L of t is differentiable, therefore L of t is continuous. So using slope on the interval from 1 to 3, calculating L prime of t, which would be 176 minus 156 over 3 minus 1, which comes out positive. Then calculating the slope on the interval from 3 to 4, L prime of t comes out negative. On the interval from 4 to 7, L prime of t is positive. On the interval from 7 to 8, L prime of t is negative. And then on the interval from 8 to 9, L prime of t is also negative. So if L prime of t is positive and then negative, then by intermediate value theorem, L prime of t must equal 0 one time in that interval. And then L prime of t is then negative and positive, so there would be the second time. Then positive to negative, there would be a third time. So by the intermediate value theorem, L prime of t would have to equal 0 at least 3 times on that interval from 0 to 9. So for part D, they give us a rate at which the tickets are being sold by this function called R of t. The question wants to know how many tickets were sold, so we're going to have to anti-derive that rate equation. So we're going to anti-derive R of t from starting what time and ending what time. We're going to be sold at 3 p.m., so that's our ending time, and then what's the starting time is that time is equal to 0 or time is noon. So anti-deriving in the calculator to get 972.784, but it did say the nearest whole number, so 973 tickets.